Hello and welcome. Today we're going to look at a three-sum problem. The statement is as follows. Given an integer array nums, return all triplets nums of I, j, and k such that I different from j, I different from k, and j different from k. And nums of I plus nums of j plus nums of k is equal to 0. And very important, notice that the solution set must not contain duplicate triplets. So for example, if we take the first one, minus 1, 0, 1, 2, minus 1, minus 4, we have minus 1 plus 2 equals 0, and we have minus 1 plus 0 plus 1 equals 0. But we might have two minus 1, 0, 1 triplets, but in this output we only want to have one of them. We do not want to have any duplicates. Another example is example 3, where you have 0, 0, 0, so again you only have one result, one triplet. You don't want 0, 0, 0 multiple times. And in example 2, it is showing us that we might have no triplets as a result, because maybe nothing sums up to 0. In this case we have 0, 1, 1, so whichever way you select I, j, and k, it's not possible to get a sum of 0. You will get a sum of 2 in all cases. Okay, so let's take a look at an explanation and the drawing, and go through the example. So we have here minus 1, 0, 1, 2, minus 1, and minus 4. So minus 1, 0, 1, 2, minus 1, and minus 4. Okay, so how would we approach this problem? So we know we need to iterate through this array somehow, right? And we know we need 3 indices because we have an I, a j, and a k. So one way is to just pick one of them first, and this one is I. Okay, and then we have to pick j and k. Well, we can pick j as the next item, and we can pick k as the last item. So then what do we do? Well, when we can use the last two to iterate, so we can say while j is less than k, then I can iterate either j forward or k backwards, depending on what I have. So if nums of I plus nums of j plus nums of k is less than 0, we need a bigger number. Then we go j plus plus, and we go to the right of this array. And otherwise we do k minus minus and go to the left of the array if we want a smaller number. But notice that what I've just described doesn't work for the current array. Why? Because the current array is not sorted, right? So the first thing that we can do for this problem is to sort our input array. So we have minus 4, minus 1, minus 1, 0, 1, and 2. Okay? So now let's try again. Let's select I as the first one, j is I plus 1, and k is size minus 1. Okay, so we have I, j, and k, and we have the sum minus 4 plus minus 1 is minus 5 plus 2 minus 3. So we need to go right with j to increase our our sum. We have the same item here, which we don't really want. We will discard duplicates. We will see more about this later. But for now, we go to the next item, next number. And yeah, there we have minus 4 plus 0 plus 2 minus 2. So we are getting closer. We increment j again. We are here now. Minus 4 plus 1 plus 2 minus 1. So we're almost at 0. But now we have to increment j again. And what do you notice? That j and k are now equal. So j is no longer less than k, which means that we have to iterate again with an incremented I. So we remove I, j, and k, and we start again from I for the next position. Then we set j as I plus 1, we set k as the last one, and again we check the sum. Minus 1 plus minus 1, that's minus 2 plus 2. Oh, that's a solution. Minus 1, 2. Okay. Next, we increment, we want to, what happens in this case? We increment j and we decrement k because we considered both of those numbers. So j is going to be here and k is going to be here. So this happens in one step. Now I have minus 1, 0, 1. Wait, that's another solution, right? Minus 1, 0, 1. Okay, that's great. So we continue because we could have multiple solutions. So we increment j and we decrement k. So j is here, k is here, and notice that j is not less than k. So we finish this iteration and we increment I again. So I is going to be here now. We'll just move this a bit. Okay, so now we set j as the next element and k as the last one. And we have minus 1, 0, 2. We go left with k. Now we have minus 1, 0, 1. Notice that we already have this item. We have it already in our solution list, and we know that we are supposed to discard duplicates. It's in the problem statement. So actually, we do not even want to consider this item. I equals the second minus 1 at position at index 2, because the previous one is also minus 1. So we'll check if I is greater than 0. So if it's not the first position, we check the one before. If I equals to I minus 1, continue. So actually we remove this entire iteration here and we go to the next one. I, j, k. And here we have 0, 1, 2, sums up to 3, and there's nothing we can do about that. So 3, we want something smaller, so we'll go with k to j's position, but that's not valid, so we exit the loop and we don't find anything else, and we're done. So that's how this algorithm runs through. I hope the explanation helps you to get to the bottom of this problem, to get to a solution. It's not that difficult. I will start coding it without taking the duplicates into consideration, and then we'll add the code for the duplicates as well. So let me go to code. So first thing, I said we want to sort our array, right? Because otherwise the problem is more difficult. Nums begin, nums end. So this is a O n log n operation. And then we fix I, first position. Then we go to nums of I size minus 2, because we want to have j and k, right? So if we go further than that, then there's no way to set j or k, both j and k, to the right of I. So it's enough to go to nums of size minus 2. So then what did we say that we were doing? We were setting j to plus I plus 1, right? And k to nums of size minus 1, to the last one. And then we said that while j less than k, we were iterating through this in this way and checking if nums of I plus nums of j plus nums of k equals to 0. And if this is the case, we want to increment j with decrement k, and we want to add the solution to our result. Or the result to our solution, maybe. Vector int, I'll call this res. Okay. And here I'm gonna say res I could have used the place back with the parameters, but okay. And return res. Okay. So if we have our solution, we increment those j and decrement k, else if nums of I, nums of j plus nums of k is less than 0, we increment j, go right, else go left in the array, right? Because it's sorted. So we know that elements to the left are going to be less than or equal to elements to the right. Okay. So now we have to also handle the duplicates. So here, discard duplicates. If I is 0, then there's no duplicate before it, right? So there's no point in checking that. But otherwise, if I have this case, we just continue to the next element. And if we found a solution or a valid result, we still have to discard duplicates for j and k, which we haven't done yet. So here we could have multiple duplicates. So while j less than k, and nums of j plus nums of j plus 1 plus j, and while j less than k, and nums of k equals nums of k minus 1 minus k. And I'm just going to add a comment here, discard duplicates, just so it's clear. Okay, so now we discard all duplicates and we should be good to go. Accepted and accepted. Okay, so that's it for this problem. Notice that we did an on log n operation here, and then we have basically on and on. So that means we'll have on square time complexity on square, because that's worse than on log n, and space complexity is O1 because we don't store anything except for the result, which is requested in the problem. We don't store anything extra, no extra space. So that's it for this problem. I hope you enjoyed the video, and stay tuned for more C++ solutions. Thank you and goodbye.